Welcome back to lesson 6.2. This is video 2. Now that we've talked about the four basic operations of functions, addition, subtraction, multiplication, and division, let's introduce something new, and it's called the composition of functions. The composition of function g with function f is h of x equals g of f of x. So everywhere you see the parentheses, you say of. So g of f of x. Okay, so what that means is you're going to actually take f of x and use that as the input for g. So the domain of h is the set of all values such that x is in the domain of f, because you're going to have to evaluate f of x, and then f of x is in the domain of g, because that function value, that f value, is going to be what you plug into g. So g has to be defined for that value. All right, so let's look at a little diagram of what's happening. So we get an input from the domain of f, that's our x value, and we run it through f, and we get an output of f. And of course, that's part of the range of f. Now f of x becomes an input for g, so it needs to be part of the domain of g. And we finally get our final output of g of f of x, and of course g then is part of the range of g. All right, let's look at some examples. The first one is a standardized test practice example. We're going to let f of x equal 2x minus 7 and g of x equal x squared plus 4. What is the value of g of f of 3? So they're giving a specific input value, a specific x value. Okay, another way of reading this is f of input equals 2 times the input minus 7. So for the f of 3, we're going to use 3 as our input. Then we're going to take that result and plug it into g. Okay, let's get started. Find f of 3. So f of 3 means 2 times 3, because that's our x value, minus 7. So that gives us 6 minus 7, which is negative 1. So now, this output of f now becomes our input for g, because we're going to take this value, negative 1, and plug it into g. Why are we plugging in negative 1 for g into g? Because negative 1 is equal to f of 3. So we want to find g of f of 3. Well, f of 3 is negative 1, so we want to find g of negative 1. So we're going to have negative 1, the whole thing squared, plus 4. So that's 1 plus 4, which is 5. So the value of g of f of 3 is 5. So that makes the correct answer D. All right, now we're actually going to find the compositions of functions. We're going to let f of x equals 4x to the negative 1 and g of x equal 5x minus 2. So we're going to find the following. We're going to find f of g of x. All right, f of g of x, we want to take the rule for g of x equals 5x minus 2, and we're going to use that as an input for f of x. F of an input is 4 times that input to the negative 1 power. So we have 4 times f of x minus 2 to the negative 1 power. Remember, that means the reciprocal of f of x minus 2. So this is saying 4 times 1 over f of x minus 2, which gives us 4 over f of x minus 2. Now let's go the other way. Let's do g of f of x. Well, f of x is equal to 4x to the negative 1. So now that's our input for g. So everywhere we see x in the original rule for g, we're going to put in 4 times x to the negative 1. So we have 5, that's part of the rule of g, and then times the input, so times 4x to the negative 1, and then minus 2. All right, 5 times 4 is 20, and then we have the x to the negative 1, and then minus 2, so we're going to do 20 times the reciprocal of x, so 20 times 1 over x is 20 over x minus 2. All right, now we want to find f of x. So we're going to find f of 4x to the negative 1, because f of x equals 4 times x to the negative 1. So we're going to take 4x to the negative 1 power, and we're going to plug that in for x in the rule for f. So we'll have 4 times 4x to the negative 1, all to the negative 1 power. So inside the parentheses, let's raise both of those factors to the negative 1 power. Okay, we've got 4 times x to the negative 1, so that outside negative 1 power we can just apply to both factors. So we're going to have 4 to the negative 1, and then x to the negative 1 to the negative 1. So we're going to multiply our exponents, and we get x to the first, which we let be understood, because negative 1 times negative 1 is 1, and a power of 1 is left to be understood. Okay, 4 times 4 to the negative 1, that's 4 to the first times 4 to the negative 1, so 1 plus negative 1 is 0. So we have 4 to the 0 times x. 4 to the 0 equals just 1. 1 times x is x. Okay, for part D, we're going to find the domains. The domain of f of g of x consists of all real numbers except x equals 2/5, because g of 2/5 equals 0 is not in the domain of f. Note that f of 0 equals 4/0, which is undefined. The domains of g of f of x and f of f of x consist of all real numbers except x equals 0, again because 0 is not in the domain of f. So how did they find the x equals 2/5? Well, we know, let's go back to where we can see the rules. We know that we can't plug in 0 for x. If f of x minus 2 is going to be the input, okay, what you can do is do 0 equals 5x minus 2. Okay, 0 equals 5x minus 2 is going to give you 2 equals 5x. Divide by 5 and you get x equals 2/5. Okay, you just have to find the value of x that's going to give you g of that value equaling 0. In other words, you got to find the zeros of g of x. Okay, guys, that's it for this lesson. Next class period, you'll get lots of opportunity to practice the composition of functions and working with those domains. You'll be experts at it in no time. I'll see you in class.